So without further ado, I will introduce Matthew Campagna from AWS. I'll let him introduce himself at the beginning of his talk. Everybody give a nice round of applause for Matt. Thank you. If you want to, you can use this. You can flip.
Great. Thanks. So I'm Matt Campagna from Amazon Web Services. I've just a short agenda. I'll talk about some PQC adoption timelines that organizations have put out and how that aligns with AWS's migration plan that we also published last year. A little bit about the cloud, some things that are unique, I think, to the cloud that can help aid people in their transition to post-quantum crypto, as well as some practices that are used in cloud services that, if adopted elsewhere, can also help accelerate just any sort of crypto agility opportunities that they see, along the lines of continuous integration and deployment pipelines. I'll call out some of the recent things that we've done since the publication of the new FIPS algorithms, some complications that we see around using ML-DSA in managed services, in a managed key management service, and then some of the general work ahead of us to resolve those. So last November, NIST published in their internal report, 8547, kind of, it has a name like the timeline for adoption of PQC, but it's really about deprecating the existing traditional public key algorithms, where they're calling for deprecating of the 112 bits levels by the end of 2030, and disallowing all the traditional public key algorithms the end of 2035. And I expect, like many of the NIST timelines, this is the current plan. And as the reality of how fast the industry is moving or how fast quantum computing is developing, these may change. CNSA 2.0, of course, they published originally in 2022, but they updated their timeline guidance in December of 2024. In particular, they have any existing non-CNSA national security system solution has to be migrated to CNSA 2.0 6 months after the publication of the new CNSS P15 guideline. So that was published in March earlier this month and sets a timeline for how soon some of these systems have to migrate, which is incredibly short amount of time. Also, CNSA 1.0, they say it's okay till the end of the year. And during this whole period, of course, these new CNSA 2.0 requirements are essentially preferred over the classical schemes. So they have a goal of all new systems being upgraded, new acquisitions by January 1st, 2027, and eventually getting them all their systems migrated by the end of 2031, well ahead of the national security memo in the US that kind of sets out the goals for NIST and NSA to transition the federal and national security systems by 2035. So our timeline strategy, of course, we're trying to at least meet these requirements as we build our systems. And in December, we published our sort of 4 work streams that we're engaged in migrating AWS and its services. We look at work stream 1 as an ongoing service, an ongoing work stream, like we're iteratively doing this as we engage in use cases in these other work streams. Work stream 2 is for the confidentiality, all the long-lived confidential links that we have, essentially coming, first and foremost, coming into and out of AWS, that our customer data is traversing. And there our approach is to deploy PQ hybrid for these internet-facing protocols. Work stream 3 is around standing up new capabilities for long-lived roots of trust, things for like firmware signing or code signing, or attestation of equipment within our networks. So we're working to build that into our key management service. And then finally, work stream 4 is all the other use cases, including real-time authentication of communication protocols, as well as all our backend systems. And so the work streams, while they're all happening in parallel, we view workstream 2 as the one that will complete first, followed by workstream 3, followed by workstream 4. This is sort of a generic, almost, while it looks complex, it's almost cartoonishly simple for how cloud services work. Customers come in through some web API to some front-end system, goes through some load balancing to get to some persistent storage of whatever that service is storing, and then a bunch of back-end services that are trying to execute whatever it is that the customer is asking this web service to execute. And customers come because of the scalability, the pay-as-you-go. You remove all the management of this infrastructure, the housing of these data centers, and customers progress in how they build on AWS over time. In order for customers to get their compliance needs, security and compliance needs, cloud services, AWS, other cloud services have this notion of a shared responsibility model. And at AWS, we think of it as we are responsible for security of the cloud. And in particular, meeting our customers' requirements. So if they have security or compliance requirements, we need to build the tools and that capability into our infrastructure. So in addition to managing sort of software updates, the security of our internal networking, the power, we're responsible for exposing those capabilities to our customer. And our customer is responsible for using those access control policies, following those compliance guidelines that we set out to meet, whether it's using our FIPS endpoints or some other HIPAA compliant. We need to show customers how to use those tools, and customers need to configure and use them to make sure they have the security they need for their application. I can't quite see a clock, so somebody note me when I'm running long. One of the natural evolutions customers have when they move to the cloud, I don't think this is true for AWS, I'm sure it's true for other clouds, is that the first step is they kind of close their data center and they replicate what they have from what they had before in AWS. And that usually means that they virtualize all their servers and run it in EC2, our virtual instance, elastic cloud. And this is where they take over a lot of the same responsibilities they had before. We take care of the compute, storage, internal networking, power, keeping that hardware up to date. But they still own that operating system and keeping the operating system up to date, the platform management, any firewall rules getting into and out of that service, server-side encryption that they need beyond volume encryption, as well as managing all the security of their network traffic. The first thing they realize is, oh, that's a lot of work. Things are cheaper. If I'm running a database, they might move over to RDS, which will at least manage those database engines, keeping that up to date. But they're still responsible for, let's say the JDBK or however they're connecting to that database. They still own all the protection and securing those links, as well as some client-side encryption. And then eventually, the real value of moving to the cloud is when you re-architect your system to architect it for using the cloud, using cloud-native services. And that really is fundamentally a cost savings because you're not paying for these instances the whole time. And as you do that, you get more configurability when you're writing all the code and managing it all yourself, but you have less management to do. And that's where the cost savings really come in. But from a PQ migration strategy, it really alleviates a lot of what you need to do to migrate to PQC because you're left with really just that TLS connection. And the rest of that stack of things that you need to migrate has been transitioned to, well, that's AWS's work. And of course, we have to evidence that work and make it clear that we're making those migrations on a timely fashion. So a migration strategy in a nutshell kind of looks like this, where I look at the blue is still the whole client's responsibilities and how they have to reconfigure maybe to use these new protocols. Our first round of, or work stream 2 is around all those orange arrows. is making sure that they are quantum resistant for the long-term confidentiality of customer data. After that, we have to stand up these new post-quantum algorithms in our cryptographic services. Once we do that, most of our infrastructure is built on those same public key protocols that our customers are using to connect, and our cryptographic services to secure customer data. So now we're going to begin making all those post-quantum by having those services available to us. Another thing that's common, it's common in a lot of deployment scenarios, is continuous integration deployment pipelines. It really is a best practice in terms of software development. So we have our own open source library. It's a fork of Boring SSL that we continually optimize for AWS environment. And we continuously go through FIPS certification with this module. And we deploy that with S2N, our TLS, open source TLS implementation. And that same external set of tools that are in GitHub for anybody to use, we pull inside, and that's part of our continuous integration and deployment pipeline, and that gets sent out whenever these service endpoints sort of remerge from live and redeploy in a pipeline that has sort of fallback improvements or rollback. And I think that's an essential part. Like if people don't have pipelines or practice of continuously updating their software, that the migration is going to be more complicated for them because they don't have these mature pipelines. That same stack gets deployed in some of our SDKs, which is what our customers are really using to connect to us. And some of those TLS stacks we vend in those SDKs. Some of them are in the development environment for those SDKs that our customers are using, and some of them are on their customers' operating environment that they're using to connect to us. So it's a very complex set of customers that have to be upgraded, some of which we have very little control over. But this pipeline allowed us to go, this one particular pipeline for Libcrypto and S2N, we've been sort of working on since 2018 and deploying in hybrid in the same pipeline we in first iteration of this had Bike and Psych, which are no more, or at least not part of the current list of standards within NIST, is the same pipeline that we deploy across all of our most of our service endpoints. So once FIPS came out with 203, we were able to quickly get Libcrypto updated with those new algorithms, go through CAVP, go through the CMVP process at a lab, and get that into pending review at NIST within 4 months. And so now it's in a cycle where we're in a waiting phase, but typically there aren't changes required at that point. There's oftentimes requests for more information, but usually from then on it goes, and we don't have to modify that module. So we've already rolled that module, that new FIPS candidate out. We use that FIPS candidate wherever we deploy AWS LC and S2N in our infrastructure, even for non-FIPS endpoints, because we've proven that we can make our FIPS implementation as fast as the previous, as the non-FIPS versions. And in fact, we're finding that when we migrate other services onto this pipeline, that if they were using some other version of TLS, that the AWS Libcrypto in hybrid is faster than the system that they had been using with just classical. So it's another way in which we're able to motivate internally service teams to move to the PQ hybrid internally. And we've deployed that across our cryptographic services today. So you can go out to KMS or Secrets Manager or Certificate Manager and get a PQ hybrid connection using our Java SDK. So what did we deploy and how to enable it? This is the specification. We have the Cipher Suite's ML-KEM 768 with the 128-bit security elliptic curves. And right now, you still have to enable it on the client. Over time, that will become default enabled once you download the SDK. The other sort of service, besides the other TLS service endpoints, is the AWS transfer family. So the transfer family is one of the services that our customers will use to sort of bulk upload data to the cloud. So it's pretty simple to set up. You go into the console, you select the transfer service, you point it to an S3 bucket, which is our simple storage service, that's the default, or you can send it to something called Elastic File Service System service. And once you set it up, you can just, you select the protocol, the default, the most common one is FTP over SSH or SFTP. And it works today out of the box with OQS's Open SSH, the Open SSH 9.9, I think, PuTTY, and a few other common SFTP tools that our customers are using. So what's been implemented? This is the specification. Again, ML-KEM with the 768 with the 128-bit security level elliptic curves, and ML-KEM 1024 with the 192-bit security level elliptic curves. And right now, it's just the default transfer security policy. It's the most recent policy that was updated this month. So talk a little bit about cryptography in the cloud and digital signatures. Sort of quickly how KMS, our key management service, works. It's our sort of backend system, our FIPS 140 level 3 HSMs that run in a fleet. They share what we call a domain key. We have KMS on the front end, which has access to a storage tier, what we call encrypted key tokens, which are encrypted customer keys. So when you want a key, you send in a policy like any other resource within AWS. It has an address and a policy that says who can use this resource for what APIs. The service will then create that key on your behalf in the HSM, encrypt it, export that encrypted key back, and give you the ID. Later on, when you want to sign something, you send in the message with the key ID. We look up the ticket, do the signature. Seems pretty simple, pretty straightforward. But this is a cloud service, so what happens in reality, it looks a little different, but again, cartoonishly, it looks like any other of these web services. But it has to keep up with our most demanding services. So S3 can take calls of tens of millions of transactions per second. That would flood a smaller service like KMS. If we were, like, let's say, encrypting every object that was being stored in S3. So we have to limit the data plane. We have to restrict the data plane, and this is true of like pretty much any distributed service. You want to make your data plane such that you're not mutating the state of the service. So you want to keep that fast, and you want to keep it from mutating state. And that means the data plane, we have to restrict how much data we can take in. And today, KMS will take in 4K of data. And you can see immediately if you're trying to sign, let's say, an ML-DSA 1024 certificate, you'd now be hashing outside of the HSM. And you might not want that for a CA. The other part is the control plane is a little more expensive because you have to replicate state. You have to assume when you're building a cloud service that your data plane handles concurrent calls. They're all happening at the same time. So doing something like managing a state of a key where you're backupping and restoring it into an HSM is going to, one, make stateful hash-based signatures kind of a non-starter for AWS key management service. And as a result, it wasn't built, even though that standard has been around for a few years. And it's been part of CNSA 2.0 since 2022. So these things are painful. So we have a restriction on the data plane because of the performance, and we have a restriction on the control plane, or at least keys that require state. So what we do today, we've been signing things with ECDSA and RSA, is customers can just send in the message. If it's small, we'll do the digesting and give them the signature. But if they have a larger thing to sign, then we just tell them to hash it, send us the hash, and they send it in, and they get the result, the intended result. And then you have to trust the customer. It's kind of the shared responsibility model. The owner of this private key has to do the right thing and ensure that he's using the service properly. And I'm sure people have all come across, well, a lot of people have come across that ML-DSA and Hash-ML-DSA are fundamentally not the same thing. And the result of that, for me, the result of that for our customers is we can't offer the same simple interface, right? We either have to pick one and do something different than maybe an unwise according to the spec, or we have to figure out a way around that. So one problem, one problem didn't show up. Okay, it's still in black. The other problem is trying to explain to the customer that these are different is going to be a pain. There's some black text that I must have messed up. So customers have this expectation that they will get the same result, even though these are two different algorithms and it won't work. And that'll be a bad customer experience. And I think, there's been a lot of conversation on the PQC forum around this, and I want to thank NIST for, I think, last week clarifying some of the requirements around external mu that allows us to at least create the external mu, have the customer send that value in, and then we can do the signing on that value. So that was great. That clarified, that unblocks where we were kind of stuck in engineering this solution, because we want to get that out in a relatively short amount of time, because we need that to transition the rest of our infrastructure, as well as our customers need it for long-lived roots of trust. So we're, I think, essentially unblocked, although this is new from last week. So we continue to work on that. So thanks to NIST for clarifying. A few more notes on signature. Just these are more, I guess maybe they're my opinions, but like session authentication just simply doesn't have the same sense of urgency, things like long-lived roots of trust or confidentiality has. And so that is naturally lagging in the PQC migration, right? The CAB forum still has to, I'll say essentially establish exactly what they want in a web trust audited CA. And until that's done, there's always the possibility that we have a lot of re-engineering back into the way we've built something, like no external mu. It could be one of the things that they require. The other thing is, we have a long history of managing multiple algorithms in root trust stores. My old job was, world domination for elliptic curve cryptography. In the early 2000s, it was very difficult to try to get root CAs established and servers to use ECDSA, because you couldn't afford to annihilate a small percentage of your customers who hadn't upgraded their browsers to use elliptic curve cryptography. And now TLS servers are much more robust. They can dual home certs. Things have changed. And I think, like when it comes to real-time session authentication, there's really, I just don't see a need for composite. And this idea that we can just seamlessly transition from one root to the other. So where we might require composite for these long-lived roots of trust, that because of our security policy, we decide to burn in keys as soon as possible, or may have already burned in stateful hash-based signatures and want composite for some period of time. I think the evolution of real-time session protocols should just avoid it altogether. So I get another opportunity on the panel to talk about that, I think. And finally, the other sort of red herring here is, or potential surprise, rather, is the signature standards are not done. Like, something else could happen here where we want some other standard, some other PQ algorithm to underlie our CA browsers, let's say, or browser form. Or the browser form may change their strategy altogether. There's been some work on the Merkle trees for certs, which is an alternate way to use these certs for TLS session negotiation. So sequence events, as I see them, here are the things that we've done since the launch. We were able to get ML-KEM into a FIPS module in process for FIPS. We're able to launch it in our primary pipeline for TLS and make it available in our crypto services. We're able to get PQSFTP in our AWS transfer service for long-term confidentiality of customer data coming in and out of AWS. We have a lot more to do. In particular, we got to continue to roll out that pipeline to our other services, our big data services like S3 and DynamoDB, and get them to take these new Cypher Suite policies. There's going to be ongoing work to get that into all the other SDKs, some of which we don't control. The different types of SDKs has to be done. We need a way of telling customers the PQC state of our services. I don't know exactly what that'll look like, but it is a #1 request. Like, we'll put out a blog eventually around the launching of these crypto services and about the transfer family. But that's not a real, it's less remarkable. We're not going to put out a blog when we get service 233 or service 234 on the PQ. So, but customers still want to know, is this service PQ? And is it just confidentiality? Is it all authentication? Is it all the way down the stack? That's what they really care about. Finally, our plans are to offer ML-DSA in AWS Key Management Service so that we can integrate that into our PKI services. So it's pretty clear at this point that we can't do all this work. We're not doing all this work. We're leveraging a community of people doing the work. I think that's true for everyone that's doing any of this work, like NIST. I think we'll frequently say they're relying on the community to do some of this analysis. CNSA is really helping, is really a call for what they need industry to produce for them. The IETF is, I think, doing an excellent work of trying to build these new PQC algorithms into the specs. Debate will continue there. And then, of course, these collaborations that the National Cybersecurity Center of Excellence, that's got their PQC consortium, that's running some of these interoperability, writing about them in their reports. I'm looking forward to the next version of that initial report. And the Linux Foundation Post-Quantum Crypto Alliance, which funds projects like Open Quantum Safe. So all those things are essential. We're using all of those things to help build our tools and our services, and we need them to build their tools and services for the people who are engineering to those things, because that's where our customers are using. Probably a lot of the people in here's customers are using as well. Okay, so hopefully, I should have looked at my watch. Oh, I've got 7 minutes, so I'm happy to take any questions.
Hi, my name is Haas, and I have a question around hybrid signatures. You a bit hinted at that, where that's going. But are you thinking about offering that as a service, the hybrid signatures, for sort of like, customers who might need that or appreciate a transition plan?
So in our sort of push to get ML-DSA out and integrate that like into PCA, which is our private CA, and our signer, which is for code signing, firmware signing, we haven't started any work to sort of say, hey, if a customer wants like some specification for composite, like, will we do all the key management? So if you write this policy, if you wanted to build, let's say in KMS, hey, I want a key pair for ML-KEM or ML-DSA 768 and P256, and I want to tie them together. So the policy must be the same for these two keys. Every time I do a signing operation, I have to sign with both. Like, we have not started that engineering, and so right now that would still be like that would currently be a customer's responsibility. If there is significant demand, like many customers all want the same sort of specification, we are likely to build it to facilitate that. Because anytime we can, lighten the load of what our customers have to do in terms of their side of that responsibility and us to build some compliance tool for them, we will do that. But at this point, there's not a plan.
Hey Matt, so this is Raphael from Meta. I think at some point you mentioned about your hybrid deployments being faster than the existing classical ones. Can you elaborate a little bit about what kind of optimization have you done?
Yeah, so like, we have, I gave you my idealized TLS pipeline. We have other TLS pipelines that our services are using. So like OpenSSL.
Oh, okay.
Some of them are OpenSSL. And so, like, we're finding, like, the latest AWS LC FIPS 3.0, which is the one that's in review, the optimizations we've made to the underlying elliptic curve primitives, essentially, is what's giving you that performance increase.
Hi, here's Guiling from Singapore. So could you please go back to the slides for CNSA timelines?
Yeah.
Yeah, maybe third or fourth, quite early. Oh yeah, here. So I'm not very clear about, you mentioned the CNSA 1.0, I said something like in the third quarter of 2025, no CNSA 1.0, but later, also there is another one, yeah, down, in the bottom of the line. So the CNSA 1.0 acceptable for all products.
Right.
Even at the end of 2025.
So the other
mean,
thing that was in the document was in the CNSA 2.0 saying CNSA is valid to the end of the year to build and procure products by the end of this year, which leaves like, kind of a gray area for what's going to happen between 2006 and 2007, where, it doesn't say exactly, like all new acquisitions in 2007 have to be CNSA 2.0 compliant, but I guess that means, and it may be true, that no acquisitions happen in 2026. But I guess you could still buy a CNSA 2.0 compliant thing in 2026. But so it's a little bit of, like the first time I went through this, it's written in text. And I tried to make sense of it in bar graphs, and like their old one that they had use case graphs for migration, which made sense and was pretty clear. And then they rewrote that in this prose, I guess, in a paragraph, and it doesn't have that same, like, it's a little confusing. So take this with a little, grain of salt, or I hate trying not to use expressions, but. Be a little skeptical that I got this 100% right, I guess.
Okay, yeah, that point. Yeah, thank you very much.
I think we got time for like one more question, and if you're our NCSE rep,
thanks for the talk. I was wondering, are there plans to move to a post-quantum only solution at some point?
Yeah, it's certainly on my mind, especially for some of these transitions internally that I look at that are complicated. We don't. Right now, we're still in a hybrid for confidentiality way of thinking. I've often speculated that there'll be more changes ahead. Crypto agility is about expecting more changes, and confidentiality is always going to be sensitive to this harvest now, decrypt later attack. And if the protocol can handle it, performance can handle it, maybe we'll just keep hybrid in some other form. So when we're confident elliptic curve may no longer be providing value, I'm hopeful that we have a new post-quantum algorithm that's even better in terms of performance, but maybe it's still not quite trusted and we want to start using that as well. I don't know, it's at some point, I think it's going to make sense to go to PQ only. But right now, I'm still in a hybrid frame of mind.
Thank you.
Thank you.
So without further ado, I'll go ahead and introduce the panel here. Trying to do everybody in order here. So we got Dustin Moody. Dustin Moody is a supervisory mathematician at the Computer Security Division at NIST, leads the PQC project at NIST, and his research interests include elliptic curves and their applications in cryptography. We have Douglas Stebila, associate professor of cryptography at the University of Waterloo. Research focuses on improving the security of internet communications and protocols and developing practical quantum-resistant cryptography. Co-founder of the Open Quantum Safe project, an open source software project for prototyping and evaluating quantum-resistant cryptography. We have Matt Campagna, lead cryptographer, who we've already heard from earlier today from AWS, where he oversees the cryptographic engineering across AWS and previously led the cryptographic research teams at BlackBerry, Certicom, and Pitney Bowes. And last, but certainly not least, we have Deirdre Connolly, who does cryptography at SandboxAQ as a standardization research engineer focusing on post-quantum migrations. She's co-chair of the TLS working group at IETF, co-organizer of the High Assurance Cryptographic Software Workshop, Black Hat Cryptography Reviewer, and co-host of the podcast Security Cryptography Whatever. Did I get that right? Yes. All right, excellent. So we're here to talk to you about hybrid. So this is a pretty controversial topic, and I'm going to hazard a guess. I'm a little worried about the controversial topic because I think we might all be on the same side up here. So we'll see how it goes. But please do not be shy. As an audience, we'll kind of go through with some canned questions here earlier. Then we'll open it up for what I hope is an interactive session, given the topic. So, first question to the group. How do folks need to consider hybrid versus pure differently for different platforms and components? This could be, I'll let you take this however you want. Grab a microphone, make sure it's on. But this could be protocols, this could be platforms, hardware, firmware, software. Deirdre's ready to go. Go, Deirdre.
I would say it depends. For key agreement, there seems to be a ton, especially on protocols and companies and platforms that are internet facing and any implementation that is able to move a little bit faster, they're going for hybrid. And a lot of them are going for hybrid with ML-KEM and elliptic curve, such as in TLS 1.3, SSH, I think IPsec is also implementing this, and there's other places. And they are generally able to do it in a straightforward manner, and they're able to roll it out sooner because they're getting the hedging against a possibly weak implementation, but they're able to react quicker, both at the protocol level and the implementation level and the deployment level. And then there's some messaging schemes like iMessage and Signal. They have also updated, they're kind of in the same position. They've updated their key agreement to be hybrid and already rolled it out. For authentication, it's a different story. I think the threat model for authentication is kind of further out and time boxed versus the threat model for key agreement in the present, which is the threat model of store now and decrypt later attacks is basically active right now. And so all those people who are rolling out hybrid key agreement now are doing it to mitigate a live threat. But authentication is a different story. So if you're able to hold off on migrating your classical authentication and signatures and certificates to something that's quantum resilient, whether that's hybrid or not, you are kind of putting that off because you don't have to do it right today unless you are signing things today that need to be verifiable 20, 25 years in the future, which some parties definitely need to do, such as US national security systems. So it very much depends. And it also depends on the capability of your org or your protocol manager or whatever it is about explicitly how you do hybrid, especially in key agreement. iMessage, Signal, TLS, MLS, IPsec, and SSH all do hybrid key agreement differently.
Yep, and it's interesting you point out a few of those. Some of the early adopters that we've seen are some of the folks that actually control both, what I would call both ends of the communications channel. It's easy for them. That's why you've seen them kind of move first. I'd like to pick on Matt in particular because same topic, but Matt, you work for a company where global international interoperability is clearly a big thing, right? It's very important. So does that change like how you guys are at AWS are approaching hybrid versus pure?
I'm not sure it changes. I mean, in a perfect world, there would be one crypto system that satisfies all our customer needs. That's not the case. There are some, I'll say, disjoint communities around the world where they don't agree. There's no overlapping solutions. So we build to be able to accommodate that. So we will have different TLS, let's say, stacks for different regions. It's not ideal because our pipelines are, for the entire, multi-region, the way we push them out. We don't do one full region all at once. We kind of split it up. So it's not ideal to have multiple pipelines. They're complicated enough. But we will, if those are what our customers require. And I will say, like, going back to hybrid, just a bit, like, there is, I forgot the number, there's another CNSS or some requirement that the federal government has of dual layer encryption. And when you push on that, when you're building that, so we had to build dual level encryption in our storage service because we had enough customers that said that they also wanted that. And we were able to do that with the same algorithm, oddly enough. They were satisfied with slightly different key management systems and different implementations of algorithms to rule out implementation flaws that might exist in one versus the other. So I do think, like, one way or the other, there'll always be a reason for dual layer or hybrid of some sort for protecting high assurance data.
Yeah, I agree with what's already been said. It's going to depend on who you are, your organization. NIST has been a little bit agnostic in terms of we're not saying you should do hybrid, we're not saying you shouldn't do hybrid. We're just trying to make sure that you can do hybrid if you'd like and you can get it validated through our validation programs. But the choice is going to depend on the application and user because there's different trade-offs involved with it. So.
Sure, I just wanted to pick up on something Deirdre said. So you listed a whole bunch of protocols and how they're all doing hybrid slightly differently. And also combining that with what Matt said about the need for different algorithms in different jurisdictions. I mean, we're seeing a risk of like this combinatorial explosion of algorithms and hybridizations and protocols that are being inserted into. And so I think there is a risk of the complexity here really exploding and setting us back, sometimes necessarily, but many times unnecessarily, I think. I think, one of the questions is, are these hybrid solutions the same or are they different? And in some cases, they are similar enough that they are basically effectively solving the problem the same way, but just achieving the same effect, but in a slightly different way. And so I think one thing we should be careful about is avoiding unnecessarily having multiple hybridization approaches within a single protocol, right? So TLS has something, and maybe it's how you design it if you start it again. Maybe it's slightly different, but we don't need 4 different ways of hybridizing in TLS, and similarly in other protocols.
We have someone from the TLS standards, right? You're making my job easy because I was actually going to use the words combinatorial explosion. So the follow-on question to that is hybrid actually a viable end state, right? Because a lot of
In my personal opinion, as an applied cryptographer, I think it is a bad end state for all the reasons that Douglas described. If we truly believe that eventually these PQ algorithms and implementations are secure, they should be replacing, not hybridized, with things like elliptic curve Diffie-Hellman, especially for CAMs, and like you can just replace a signature with a signature. I understand that some people want hybrid as a bridge because they want to deploy things now when they're not fully trusted, and then eventually get off of the hybrid bridge to the possibly pure state. But I also have heard from other people that they think they can go to hybrid and stay there indefinitely. And because of all the reasons that Douglas described, I don't think that that will be good for general security because of the complexity, all the negotiations, the maintenance burden of having a bunch of crypto implementations and algorithms in your stack and in your software that you don't necessarily need because in theory, like all the elliptic curves and the RSA and all that sort of stuff in the old signatures is just cruft. And we should, if you are in a position to trust these new PQC algorithms and their implementations, some parties are able to feel very confident in the implementations they pick, in the cryptography itself, to do that more than others. So I understand this is not viable for all parties. Seriously consider whether you can target a pure PQ solution to being quantum resistant rather than either going to hybrid as a stepstone and then to PQ, or going to hybrid as your final destination to be quantum resistant.
Yeah. So let me play devil's advocate for just a second, right? If we let this combinatorial explosion get out of hand, combined with the fact that every other cryptographic modernization I think that I've seen in my career has arguably never ended, right? There's still MD5 out there, there's still pre-AES out there, there's still triple DES out there, check your own organization. Are we doomed if we let the combinatorial explosion get out of hand, right? Is there ever putting that genie back in the bottle? And would you forever be hybrid if it gets out of control?
I'm not sure that the combinatorial explosion is even the doom. What is the motivation to go through another migration from hybrid to pure PQ? So, I mean, even in however many years when there is a quantum computer, your hybrid solution is still secure. So, what's more expensive to you? 32 bytes of elliptic curve keys transmitted on every connection, or rejigging your entire infrastructure again?
Yeah. And what do you say that, because a lot of the folks that I work with, their biggest concern are these cyber physical systems, the ICS SCADA systems, the cars, the things that move, right? That these little distraction boxes have a lifespan of about 5 years. But industrial control equipment has a lifetime of 30 to 40 years, and oftentimes you can't touch it, especially if it might be a satellite, right? Forget touching that again. What do we do about those?
Hire a cryptographer.
Oh, there we go. All right.
Is this what we throw to the audience and ask for audience
Well,
input?
this is, like I said, like I alluded to before, I think a lot of us on stage are kind of on the same side. So I imagine that there's folks in the audience who work for organizations who are leaning towards hybrid, and I'm really interested in what some of the perspectives on why you're going hybrid. Now's your chance to ask some of the experts, why, what's the, I think you heard, or at least what I heard, was that if you do hybrid, you're sort of hemming yourself into multiple modernizations, right? You're going to go to hybrid, and then eventually you're going to go to the pure post-quantum, quantum resilient. So there are certainly instances where that is of business value and maybe the optimal choice. But I think I'm interested to hear from the group as well. Are you lined up for a question? Yeah, come on up.
Mike Ounsworth, combinatorial explosion enthusiast, I suppose. So I'm the author of The Composite Thing, which has unfortunately 10 KEM combinations and I think 30 signature combinations, because it's 15 times pre-hash. I hate it. I hate being the author of this thing, right? It's horrible. We keep trying to take options out, and someone goes, no, I need that. We keep saying, hey, this one looks useless, and then 30 seconds later, someone's like, no, I need it. And then people come and say, well, while you're tweaking the list, can we also have P521 combinations? And so then we try and take one out, and it gets 3 longer. So, and so part of the problem is the legitimate use case for the combinatorial explosion is this is what you have deployed today. This is what you've certified. This is what your auditors will accept. Even just swapping from one curve to another, like swapping from P521 to P384, swapping from RSA 4996 to 3072, is that you have to go through your whole audit again. Whereas if you can say, you accepted this last year, and you accepted this the year before, and now nothing's changed, we just added something else next to it, then your auditor goes away. So like a combinatorial explosion enthusiast, I guess, because this is hard.
Yes, going back to a previous part of my career, right, any small change, and not to pick on our colleagues from NIST who developed RMF in 853, but some of the dreaded things about making any change to your architecture is the fear of going through that certification, accreditation, and validation process all over again, which is expensive. Are there ways to shortcut that? Are there ways to do that in a healthy way?
Well, they've been working hard to reduce the timelines, to make it more automated, and we work with them as we develop the standards to make sure that what we're writing can be tested and that they can have those tests ready as soon as possible. So they're doing the best they can and trying to improve it. We know that it still takes time and there's still problems, and we're trying to address it. It's been nice to see with the PQC algorithms that as people have come back to us and said, hey, here's an issue with testing or validation, they've been pretty quick to respond and make changes to make people happy. So we're doing the best we can.
On validating hybrid constructions, I think even if you are adding something next to what you're already using and has already been validated, that doesn't make your auditor go away. You still have to get the new thing that you concatenated or combined in audited to see if you actually are doing it in a compliant way. So you are going to change something and you need to get it checked by an auditor either way. Consider going pure PQ instead.
Well, I'll touch about the FIPS certification just because we're constantly going through it. Some things that can speed up your process is, maybe don't re-architect your memory management system and make drastic change. If you're trying to get a new algorithm in, just make it an algorithm update. It lowers the amount of work that you're asking the lab to do in the recertification process. So that gets you through the lab faster to the NIST CSQ. And it would be nice, if another ask, if you could keep asking the same government organizations for things, is prioritizing that queue based on how the governments perceive their needs being met. So you could take out of that queue and say, we're going to take the post-quantum algorithms first. Modules with PQ, we're going to prioritize in the queue when it gets to the NIST CCCS review. I have a whole bunch of list of things that I'm preparing for.
Yeah, just send them over. I'll pass them on to the right people.
Okay, I've got a list. I'm going to present at ICMC and talk about ways to maybe speed up PQC, at least in the crypto module certification sense.
There we go, interactive standards development. You're in the right place. Yeah, go ahead.
Haas from Netflix, and we do pursue different strategies for different use cases, but the hybrid is definitely top of mind, at least for the reasons you mentioned, Deirdre, around early adoption, and it's mostly due to the lack of implementations versus the algorithms, why we are going with the hybrid at this stage. These are basically early adopters that are doing implementations this year in firmware, versus down the road in 2-3 years. And you're going to be revisiting that every year. So I was wondering, even with that, do you have any strong arguments to still consider going with the pure PQ scenario?
I figure when you are picking an implementation of a cryptographic algorithm, you need to vet your implementation either way. And if you're not vetting your implementation, or you do not have the resources to find someone to do it for you or pay someone, maybe you should invest in it's not even cryptographic security at that point, it's software security and supply chain security. This is the same for the classical algorithms and for the post-quantum algorithms. Yes, the post-quantum algorithms are new and they're based on newer assumptions, but Kyber, now ML-KEM, was first written up over 10 years ago. And when we started rolling out elliptic curves into production 20-something years ago, the first paper for elliptic curve cryptography was about 15 years old, 20 years old. We have a long tracker with, you know, structured lattices and all sorts of stuff. I think of it as vetting software, and you need to maintain your software dependencies, full stop. Yes, they're cryptographic dependencies and they are complicated. Go hire a cryptographer either on contract or, you know, a cryptographic engineer to audit your dependencies on a regular basis so that you can feel confident enough to deploy it now and keep it up as you go. Because we are learning lessons from these FO transform CAMs about just pitfalls of implementing them, making sure that when you recompute the ciphertext on the decapsulation side, that you actually compare the ciphertext that you got handed by a potential adversary and the one you recomputed, and change the shared secret that you put out on the other side based on that. We're learning like lessons learned of implementing the same algorithms or the same style of bugs over and over again, and that's the same for any software, any new thing that's going to be implemented in the market. So.
Hi, I'm Jack from NCC. So I think, as you mentioned, the ECC was kind of brought in moderately quickly, and with that there were a lot of people who were quite worried about whether it was safe, and some people stuck with RSA, and we see RSA everywhere. And there are still some people who really now don't want to touch it because they think there's something wrong with the small keys. And now we have a couple of different things that NIST are recommending, and NIST also have a backlog of other things which they might start recommending. HQC is kind of 2 years and almost definitely going to be standardized, and Falcon's almost there, and then there's a whole second round of DSA stuff, and other countries are picking stuff. As a kind of new problem, do you think we might move from a kind of classical post-quantum hybrid to a kind of post-quantum hybrid where no one really trusts one or the other, and you end up with this kind of awful situation where someone's like, well, maybe we should have something which is code hard and lattice hard before we start really trusting one of these or the other? I mean, if we start worrying about this between, you know, one computer attacking another, we might really start worrying about these as kind of one maths problem versus another.
So I think I would be very worried if we're getting into the world of doing post-quantum hybrids indefinitely. I mean, my hope would be for these alternative post-quantum schemes coming out in later rounds of standardization is that they're offering functional improvements. So easier to implement, smaller public keys, smaller ciphertexts, and that's the reason we want to choose them. And if those are the benefits coming out of them, then a hybrid choice for that wouldn't make as much sense. If we are getting into a world where we're doubting the security of all of them, then, I mean, that may be the world we end up in, but I hope it's not.
And I definitely think there is, I mean, these different post-quantum things have all sorts of different problems, right? Dilithium is really big, and other things are maybe smaller and very slow. But it is usually a motivation that a diversification of problems is at the core of this, like, second round calls, right? So we picked a bunch of lattice things, and there's this kind of notion of what is structured lattices are actually a problem. We should do this, and I think once that starts getting put into the documentation, it's going to be really hard to take that out. There's a huge amount of academic work now going into producing something which is not based on the structured lattice because we're worried about them. And how do you undo that? Because we've essentially started that now.
Yeah, I have heard of people positing I would like to have a classic Nicolis and ML-KEM hybrid, because over in my jurisdiction we don't trust ML-KEM. We trust something like classic Nicolis or NTRU or maybe Frodo-KEM, which is an unstructured lattice scheme, and it's more of the I have a thing that I can use over here, and you have a thing that you can use over here, and it's less about the diversity in the cryptographic problem that you trust. It's literally just I can't use NIST curves. I have to use brain pool curves, and over here I have to. It's that sort of thing again. I have also heard of people who have floated a ML-KEM HQC elliptic curve hybrid KEM just to cover all their bases. And I kind of agree with Jack that like it feels gross, and like it's kind of a little bit of the hybrid box has been open, Pandora's box has been open, when we allow the discussion of hybrids in general, because it's not just about hybrid traditional security reduction and post-quantum resistant security reduction. It's like, well, I have other reasons to go hybrid, not just because I want to, you know, rely on a specific cryptographic reduction when one of them fails. Consider pure PQ? Yeah, at least that's one less thing to worry about.
Yeah, and I'd also just add, we expect ML-KEM and ML-DSA to be the main algorithms that people use for the foreseeable future. Of course, there'll be new research comes out that'll change things at some point, but that's what we expect. We have these other algorithms there because we need to have backups in case something happens. So we understand there is a concern with, you know, standardization ongoing and more algorithms in the future, that it can delay adoption because people are waiting for newer algorithms or to see what comes out. We hope people just start transitioning to the ML-KEM and ML-DSA, and if there's particular needs for these other algorithms, then you can use them.
Cool, thanks.
All right, let's take one from the other side.
Hi, so on? Okay. Hi, Jan from Akamai. I wanted to get back to your question. You asked, Matt, you know, are we baking things in for the long run, and what do we do about this? And I would like to suggest that the industry needs to take this as an opportunity to bake in crypto agility, not bake in quantum whatever, right? Like, we will be developing new algorithms, even as you just said, like right now we're recommending these and these, but there will be new research. And I think it's a fallacy if the industry just focuses on like, oh, it's the quantum thing, that's what we're doing. If you're going through this right now and you're overhauling your inventory and everything, plan for future changes so that this whole migration will not take as long as TLS 1.3 did, and that you can actually move faster. That's all.
Agreed.
Yep. Agree, and I'll mention in my talk tomorrow, but NIST has got a kind of a sub-project working on crypto agility to encourage that. Yeah.
Back over here.
Hi, David from Project 11. So one of the reasons, obviously, people want to use hybrid cryptography is that they don't trust that lattice cryptography is post-quantum secure. So I'm just wondering, do you think we need more work from quantum computing experts trying to attack lattice cryptography to gain that trust, or what work do you think needs to be done to actually bridge that gap and have people trust ML-KEM and ML-DSA?
I'll clarify that there is the unstructured lattices basically do not have this concern. That's more like PhotoChem, but they're larger and less efficient because they're unstructured. The different kinds of structured lattices have a little bit more concern. We don't really have a good, evidence to substantiate that. Occasionally we have some, there was a paper about a year ago that said, if you have a structure of a certain kind, especially for structured lattice constructions that are fancier than public key encryption, CAMs, or the ML-DSA signatures, fully homomorphic encryption, anonymous credentials, zero knowledge proofs, things like that require a different kind of structure. But that turned out to be broken. That didn't turn out to be a true threat. There does seem to be a very small set of quantum cryptanalysts who understand the structured lattice constructions and problems, and in the world, I could basically estimate it to be 1 to 2 dozen in the world. Further research is always good to have to give us reassurances. Yeah.
Once we have a name standard, I think the value, the target kind of is fixed, and it becomes much more attractive to the cryptanalytic research community. So I think there's I think people will be turning their eyes to it more so than they have already. What's challenging with any cryptanalysis is we don't always hear about failed cryptanalytic attempts.
Yeah.
We only hear about partial progress. So we managed to shave a bit off here, or we showed that this this particular class of attacks doesn't work, but we never get full insight into cryptanalytic progress.
I'd just say time passing with continued research and study, that's the only way we've seen that confidence grows. And so it's part of the reason the process from algorithm submission to selection took a long time. We just wanted to bake in enough time. And I think that's all we'll be able to say really. We do have higher security parameter sets, so even if there are some advances, the higher parameter sets are likely to still be fine, even if the lowest level lost some bits or something.
Yeah, on that, for people making constructions that are hybrid, for example, pairing the elliptic curve X25519, which is about 128 bits of classical security, they're pairing it with ML-KEM 768, which is the third security level. It's supposed to be on paper 192 bits of post-quantum security, but they're basically pairing it with a different lower security level classical curve, basically to hedge against that kind of attacks only get better sort of thing. And if we're going to deploy it right now, adding some buffer in there for the attacks to get better, so that like maybe 10, 15 years from now, that 768, 192 bits of post-quantum security is like maybe a little bit closer to 128 bits of classical security. That's being built in not because it's a structured lattice issue, but because it's a brand new cryptographic scheme with a current estimated bound against a currently known estimated adversary of a certain capability, and just sort of with the understanding the attacks only get better, they never get worse.
Thanks.
Tommy PQC Shield. Sorry. I wanted to prompt a little bit more on the idea of a backup algorithm. I understand that we've all seen that NIST put out a draft for, or will be putting out a draft for HQC. But if I look at this from purely an engineering point of view right now, HQC is more or less strictly worse in every single way. So that brings to me the question of, it's good to have a backup, I mean, in the sense that we have a standard that we could fall back to, but if nobody is implementing that standard, then we're looking at the metaphorical excrement hitting the metaphorical fan and ML-KEM suddenly being broken, and then everyone scrambling to switch over to something that's not been built yet. So how do we, basically, how do we encourage people to actually make sure that they have the backup on standby? Is this something that we're just going to leave up to people to self-analyze if this is something they need to worry about? Is this something that we need to push people to do? Yeah, how do we make sure the backup is actually a backup?
Well, I mean, one easy thing is you can make it mandatory to implement. An implementation is required to implement these basic algorithms. So like, I don't want to put it on Deirdre's shoulder, but you could make that as part of, let's say, TLS 3.1, where you say, like, I mean, they did this in the original TLS. There were some mandatory components that you had to implement, and then you wound up turning them off, like, later on in life. So, I mean, that's one way. Similarly, CNSA could require agility between two algorithms. Even if they never use that algorithm, they could still make that a CNSA 2.0 requirement. So there are some things that we can do in a policy space or a standardization space to encourage at least robust, real implementations, even if we don't use them. So that's one way you could deal with it. I'm not suggesting that we do that. But
there's a few regulators here, so maybe if they're willing to comment on this, they're very welcome to. I'm very interested to hear that. What I find interesting though with CNS 2.0 is that you kind of see them going the very hard opposite direction. They are very hard pushing for the least number of options possible, even going as far as, okay, we're going to force you to use SHA-2 in the external interface of your modules or cryptographic systems. We're not supporting FNDSA. We're not going to be doing SLH-DSA even. It's just ML-DSA and for basically begrudging transition reasons, some stateful hashing. So yeah, the NSA at least is giving the signal that you shouldn't do this. That's something that I find kind of puzzling because it goes counter to the whole backup idea. Yeah, I'm basically also just still standing here because no one wants to ask another question. But yeah.
Did you
Good
have
points.
another one, or you? No, okay.
That's it for me.
No, those are good points. I think especially ML-KEM is like, it's gotten a lot of attention, and Kyber before it, a lot of attention, a lot of implementations, a lot of feedback to help write down the spec and have, you know, different kinds of implementations. I do think there's a plausible concern in the like literal software security of HQC implementations just out there, just because it'll get less attention, so that when, you know, if God forbid, ML-KEM just, you know, broke and you're just scrambling for an HQC implementation, it's just going to get less attention, less, you know, iterations on doing implementations and learning from each other. Yeah. Maybe NIST can solicit high quality implementations and post it on their website.
We could try, yeah. And I can't speak for the NSA because they're their own agency, and I don't think there's any of them here because with recent administrative changes, travel's not as easy as it used to be. But I think their main goal is just to make the transition for them as easy and quick as possible. So by having fewer options, that helps accelerate that, is their main motivation.
And more likely to succeed.
So one angle I haven't heard yet, and oh, the echo is a bit annoying. Attacks usually don't come out of nowhere, and also new cryptography usually doesn't come out of nowhere. And if you look, for instance, at, I mean, XQC isn't there. I mean, it's not a competition in performance for ML-KEM, but we can't expect new cryptography. Well, it could happen, but it's not likely it comes out of nowhere and be better than ML-KEM, right? It needs to be studied a bit. And what I like about having the backup, not as real backup, but the fact that there's attention to it. I mean, if you look at, for instance, the signature schemes, which were in on-ramp, if you look at them today in the second round, they're so much better than they were even, I think, last time I looked at it was even a year ago. So there's a lot can happen, and so I think that's even to those that were worse, right? So some people said, why do they even bother with the signature schemes in the on-ramp that were worse than ML-DSA and SLH-DSA? And I'm happy that they're in the running because things don't get better out of nowhere.
Yeah, agreed.
Back over on this side.
Hello, my name is Yolanda Sanz from GSMA. For those that are not familiar, GSMA represents the interests of the telecom industry, particularly the operators. So, as you know very well, the telco infrastructure depends so much on the standards. Also, the operators who provide connectivity to a variety of devices, starting from cars to smartphones, but also IoT devices like smart meterings. So all of these, so there are many dependencies that are out of the control of the MNO, particularly the telco operators, but that still they need to provide connectivity to all of these devices. So I hear a lot between hybrid approach versus pure PQC. So I'm going to ask you as an expert, what GSMA can do in order to help the operators to move to the pure PQC, considering all the dependencies and elements that are out of the control from the supply chain?
I would say come to the standards bodies that are making these decisions about the protocols that you need, and tell them that you prefer, or at least you want to be able to go pure PQ, because there are some places where they're just going hybrid and then they're, you know, not necessarily like going directly, or at least allowing pure PQ options. Making your voice heard in the places where these decisions are being made and these specifications are being written is very important. Like I participate a lot in the IETF, and there are other protocols and standards bodies as well. Having someone being there to say, we have reasons to select these options over others, it really matters.
But on that particular point, so there are certain devices in the network that have limited capacity in terms of memory and processors. So there are companies that are challenging whether these kind of algorithms are going to work for IoT smattering, just to put a simple example. So how risky is to move directly to pure PQC while certain performance has not been tested? For instance, we have in all our devices what we call the SIM card or the UICC, which is another constrained device where there is a limited capacity in terms of memory and processor. So how to ensure that migrating directly on the PQC is going to work in all of the devices that we have in the world.
Going hybrid is more expensive than going pure PQ. ML-KEM and ML-DSA are more efficient than their elliptic curve counterparts, and they work for smaller, low-power devices that are battery constrained by their radios. Sending larger public keys and ciphertext over the radio may burn more battery, but the actual computation of, doing a shared secret computation in ML-KEM is more efficient than doing the equivalent elliptic curve Diffie-Hellman over our most efficient elliptic curves. So there is more of a, if you trust the new PQ cryptography and implementations, that's one thing. But in terms of can the devices handle pure PQ, it's like they will definitely be able to handle at least ML-KEM and ML-DSA, modulo the battery burn over a radio of a couple of kilobytes. Hopefully they can amortize that over time, depending on their use case. That will be more efficient, strictly, than the hybrid solution.
And I think getting those things into the acquisition requirements, going back to my question earlier about what to do with all these operational technology components that have really long lifetimes, you need to get those acquisition requirements in today.
Yeah, the challenge I see that at least from the telecom industry is that it is not pure PQC or hybrid approach. In some cases it's PQC or no PQC at all in order to ensure, because as you point out, so if you are putting hybrid approach, you are increasing also the complexity in terms of performance and so on, just with the negotiation. But in some cases, you are here just, okay, let's not migrate to PQC and then stay as it is until the threat is more tangible in terms of cost, of course.
All right, I'm doing a quick time check. I don't want to send anybody back. Looks like we got 4 more in about 10 more minutes. So if you have an urgent question, come on up now, but I think this is going to be it. Let's go over here, because we got 3 over here and 1 over here.
I'll lob what I hope is a softball, which is, do you have recommendations for application developers? So I'm thinking of the case that came up. Panos Kapanakis did some excellent work on benchmarking recently, and it got me thinking that current web design, it's common that you load your HTML from here and your JavaScript from a CDN, and you load external media from 12 different domains, and one page load has done 18 TLS handshakes. Does this lead to some recommendations you would give for how to restructure web apps so that they can just, yep, stuff's going to be bigger? And do you have recommendations for how to design apps to tolerate that better?
Unfortunately, no, but the people who are very aware of how the large PQC signatures that are likely to be adopted in the web PKI and modern TLS 1.3 connections are very aware of the hit on their performance budget and time to paint budget and everything that a web developer currently expects as a modern performant web application or web page to the way it's supposed to behave. They're very aware of the issues there, and there's actually a lot of discussion about major re-architecture designs for instead of having 5 or 6 signatures in a TLS 1.3 connection that you have to transmit, can we eliminate one of them by having, instead of an intermediate, we have a root and a leaf in our CA chain? What if we have Merkle tree certs? What if, there's a lot of consideration that unfortunately is completely out of the hands of a web application developer that hopefully will make it so they don't have to worry about it at all. That the TLS stack and the web PKI and the browser will just eventually support PQ, and the web developer doesn't have to think about it at all. The browser vendors and the TLS stacks and all the parties involved in this are really, really incentivized to go PQ in a way that does not hurt these performance metrics as much as they possibly can. So I don't have any specific recommendations for an application developer, because hopefully they will not ever have to think about it.
I'll add, one thing that can help, just generically for developers is definitely avoid the complexity of, I don't know what your combinatorial thing is, but in TLS, having 2 or 3 possible hybrid is manageable. And like, and no, it has nothing, just generic application developer advice is don't build into your application 1,000 different schemes. Like, don't build for that complexity. If you can control the number of algorithms that you're using, reduce that down to a minimal set. Because I have that problem like where developers are building systems all across AWS and they all want to use a different thing or a different construction, and I have to provide a library that provides that, and getting them harmonized on a few repeatable designs that work for all these use cases really simplifies their development time and our delivering that crypto primitive and the time it takes to actually do the work.
I'd maybe also just add to think creatively about optimizations like amortization or caching. So, can you amortize a key exchange across multiple connections? Like we saw Apple iMessage PQ3 amortize the PQ across many steps in the ratchet. Is this the time to do more PSK or session resumption? So those types of techniques might help.
Excellent. Let's go on over here.
Hi. So this goes back to the discussion about like having a backup to ML-KEM in case, God forbid, ML-KEM is broken. So last year when Yilai Chen's paper came out on ePrint, there was some interesting panel discussion at PKC where Daniele Michanshu basically said that so at a very high level, like the lattice-based problems and coding-based problems are like noisy linear algebra. So it's quite possible that if someone breaks ML-KEM, then similar techniques could apply with some more clever extensions to break code-based problems as well. So he said that we could be in a doomed world where effectively like it's impossible to build public key encryption using, again, in a post-quantum world. So if we are in this doomed world, again, God forbid, but then how would you see this whole hybrid thingy like?
We always have hashes.
But I don't think you can build like public encryption with hashes.
Yeah, but we do have them for signatures. We're not in a completely broken post-quantum world. If that scenario were to be true, it would be very, very unattractive, but yeah. Oh, and we can always fall back to Kerberos style key agreement.
What about QKD kind of solutions?
No.
I'll just throw out isogenies where psych was broken, but there is still C-side, which uses a different idea, key exchange. So there are new research ideas too as well.
All right, back over here.
Thank you. Yeah, so Guilin from Huawei International, Singapore. So I would like to say a few words for hybrid as well. Yeah, because my main motivation is that for security, for conservative security. Because if we just assume one algorithm has a security like 99% confidence for its security, either due to it maybe got it wrong, either due to algorithm design or maybe implementation issues, etc. So either way, so if we have the hybrid scheme, so basically the solution is that one of them secure, the whole system secure. So in that case, it is easy to say with simple calculation, we can say that we can get a system with a 4-digit nice confidence for security, right? Just one of them secure will be secure. That's good. And also a good thing is that we can say a lot of the systematic work, either research and also standardization, to show that hybrid can be done. Of course, complexity could be an issue. But in that case, I think finally will be designed by customers. So what my belief is that maybe for a very, very long time, pure PQC approach and also hybrid approach will coexist together for a very long time. Just depends the use case, which scheme they will choose, they will select. But of course, it seems will be very good if anyone or any organization can do something to show hybrid, how complex, what the overhead will be, especially for digital signatures composite signature, etc. Yeah, quite a lot of our colleagues actually, yeah, like Deirdre and also Mike, also Tom, yeah, from IETF as well. So we know something there. Yeah, a lot of try, but maybe we can still say more experiment to show, especially. I also noticed like authentication or maybe PKI, etc. could be very complex using hybrid thing. Yeah, but anyway, can still do this kind of standardization and the research, and finally let the customers choose. Yeah, okay, that's what I want to say.
I do agree that I think we're going to be in a heterogeneous world for a long time. There will be some, protocols, businesses, organizations, projects that will be able to go pure PQ and be very happy for a long time. But we're very, very aware that, especially a lot of European jurisdictions are hybrid, and they're going to exist in the same software internet ecosystem as the parties that are pure PQ, and it's just going to be a heterogeneous world for a long time. I do agree.
Thank you.
So you got a hard question before, but I guess I'll let you go last. Make it easy though.
Yeah, I first wanted to briefly respond to Mike about his how do we help developers, like the not cryptography people, get things done efficiently. 3 years ago now we did a paper looking at the situation of Android, where it was a mess, where the main problem was actually not so much the developer's fault, but the way that the operating system is set up, or the APIs that they're given to the developers are set up, and that makes it very difficult to use all of the existing features that are in TLS 1.3 to reuse connections, to multiplex connections, to not do a handshake every single time. And one of the things that we saw is that we measured like the top 50 apps in the App Store, for just poked at them for 5 minutes, and there were apps that were doing hundreds of TLS connection setups. So what we need here is to give developers more tools to reuse also the features that we have built. The other thing is that I wanted to respond to the GSMA question, and also basically echo discussions that I've had last week. People sometimes basically phrase the question, when is the IETF going to be done? So that I can then use this in my other standards organization to then develop things on top of. That is the wrong order of operations. The IETF is then going to have developed things that don't fit your use case. The IETF is not going to take things into consideration, and also this waterfall style approach, I thought that we learned decades ago that just slows things down a lot. So it is really important for, if you have a use case that is going to need to transition to something that's not already done yet, quote unquote, come to the IETF meetings, come to the people talking there, and bring your own homework. Implement those experiments, see where things are breaking for you, and then let's come together to see how we can fix those sorts of things. I mean, the IETF is the collective of people working on standardization can't fix your use case if we don't know about it.
Yep.
And we're usually very, very happy to help people. That is also something very, at least at the IETF, very open environment. So don't be scared.
Thanks.
Well, thank you. That's a good one to end on. I want to give one last big thank you to our panel members. Give them a big round of applause.